We've learned about a lot of different cycles so far. What are some of the cycles we've learned about?
Water cycle.
Water cycle.
Matter cycle.
Matter cycle.
Carbon cycle.
Carbon cycle. And here's the interesting thing. Cycles don't have a beginning and they don't have an end, right? They are completely continuous. They keep going around and around and around. They start one place and they keep going back to the start. Okay? The start is what we actually pick it to be. The rock cycle is no different. Because we know that on our planet, right? Our planet is a terrestrial planet, and we know that there's a tiny thin little crust that is the surface of our planet. And everything underneath that is a really thick liquid, right? Is it hot liquid or cool liquid? What's it called? Magma. Right? So, the vast majority of our planet is actually molten. So, this whole part here is all melted rock. Okay? Known as magma. Now, the surface of the Earth's crust, the topmost part here, okay, the topmost part in green, that's the stuff we're walking on right now. That's land and oceans and mountains. And that stuff completely gets worn down after a while. Okay, in fact, there's stuff getting worn down right now. And just because the top is getting worn down doesn't mean we're ever going to run out of crust. This thickness right here never actually changes. Okay? It never actually changes because we're constantly making new crust underneath it. And crust can actually be made, rock can actually be made 3 completely different ways. So when we talk about the rock cycle, rock is always getting remade in one of these 3 ways, and it's always getting broken down from these 3 types. Okay? So when we go back to this very complicated picture, okay, there's 3 main groups of rocks here. Okay? The main groups of rocks are in the 3 corners of this actual cycle. So when we talk about this, our first one up top is known as igneous rock. Igneous rock is the hardest of the rocks on the planet. And it comes from full-on, slowly cooled magma. So as that magma that is at the closest part here, so this magma area here, which is furthest away from the core and closest to the surface, is actually a little bit cooler than the magma that's found in and around this area. This is super hot. As it gets away from that heated source in the center, it starts to cool off a little. Okay? In that section, that orange section near the bottom of the actual crust, it's known as the asthenosphere. Okay? I don't expect you to know that, don't worry about it. But it's an area where magma is slowly being allowed to cool. And when you take heat away from magma, okay, it slowly makes this hard type of rock. All of the minerals all of the atoms that you know about, okay, are slowly cooling. That means they're slowly losing heat. And so they arrange themselves in really intricate and hard patterns. Things like quartz and diamonds and stuff like that. That is slowly cooled minerals. Okay? Now, igneous rock can then get to the surface and it can get worn down. What are some of the things that can wear down rock? What do you think are some of the things that can wear down rock? So if we had this igneous rock here, okay, what could happen to rock?
Erosion by water.
Water could continuously hit this rock and chip away at it. Absolutely. What else could break this rock down?
Us walking eventually, like people walking on it a lot when.
Okay, people walking on it, yeah.
Lava.
No, what breaks down the rock? Has anybody here ever been to the Grand Canyon?
Oh, heat. Wind.
Okay, wind can break down rock. Lots and lots of wind. Now, wind has a harder time breaking down rock than water does because it doesn't have as great of a mass. Okay, but these two things are two forms of erosion. And erosion is that slow breakdown of rock. So if igneous rock basically is chipped away and chipped away and chipped away, a lot of small little sand particles and smaller rocks actually get made. And those rocks actually find themselves, as they slowly break away, okay, they find themselves falling down on the surface of lakes and things, and they start making layer upon layer upon layer upon layer. And basically rock that is allowed to form layer upon layer upon layer like that. So if I do that, we'll say here's one layer, and then a different kind of layer sets on top of it, and a different kind of layer, and a different kind of layer. This forms sedimentary rock. Sedimentary rock is not as strong. Okay, sedimentary rock is, if you've ever been to the Grand Canyon and you've seen water, basically the Grand Canyon used to be at the surface, at the topmost part of the canyon. It used to be a river, and it's slowly eaten away at the rock, and because the rock is so soft, it's actually gone quite deep. And if you look at those images, okay, of the Grand Canyon, you'll see that there are horizontal layers there of rock. Different colors usually, because they're different elements. They're different types of elements. Okay? So igneous rock can become sedimentary because of erosion. Right? Now, this sedimentary rock and igneous rock can both be basically exposed to a tremendous amount of pressure, because the lower down you go, those lower layers have all the weight of the layers on top of them. And if those tectonic plates are still moving around and there's two tectonic plates that are crashing into one another, they can actually apply a huge amount of pressure on top of these layers. And they can actually cause these layers to actually bend. Okay, and this is how some mountains are formed. Okay, these bending layers like this, okay, this actually gives rise to metamorphic rock. Now, igneous rock can become metamorphic if two things are applied. Igneous rock can actually become metamorphic if pressure and heat are applied. Sedimentary rock can become metamorphic rock if pressure and heat are applied. Okay? Metamorphic rock. Once that rock that's really deep under the ground bends, metamorphic rock is subject to erosion. As soon as something's on the surface of the earth, it is subjected to erosion. You can have biological erosion. Have you ever seen mountainsides or hillsides that are rock and then out of nowhere there's a tree growing there? Well, that tree has roots, and those roots are digging into the rock. And as they find little cracks in the rock, they make those cracks bigger. So more chunks of rock fall off. So you can have wind erosion, you can have water erosion, which is very common, you can have biological erosion, and you can also have chemical erosion. With some of the pollution that we put in our atmosphere, it creates acid rain. And acid rain can eat away at certain types of rock. Okay? So metamorphic rock can also undergo different forms of erosion. Right? And if these actual types of rock get far enough down into the crust, they melt. Right? When they get pushed down, we've got a subduction zone here, and they actually, one comes into contact with another, and it gets pushed down. That plate that gets pushed down, if it's sedimentary rock, it's going to melt in the mantle. And when it's allowed to cool, okay, through slow cooling, it can become igneous rock again. So this is through slow cooling. Metamorphic rock, okay, that actually gets subducted, or that gets basically eroded away, and it can too become magma again, and it too can undergo slow cooling to actually become igneous rock again when it makes it to the surface. So if you actually look at this image, all this image is doing is it's telling you of the three different types, okay? It's telling you of the three different types of rocks here, right? We've got our igneous, we've got our sedimentary, and we've got our metamorphic. And it's telling you that you can actually go from igneous to sedimentary. It's telling you that you can go from igneous to metamorphic. It's telling you that you can go from sedimentary to igneous, sedimentary to metamorphic. It's doing the exact same thing that we just talked about. And it's just outlining the different steps that have to happen here. Okay? The rock cycle is never ending. The rock cycle is rock on this planet, okay, while it's in the Earth's crust, is continuously going from one form of rock to another. An additionally clear image of or picture of the rock cycle, okay, I'd like you to look at pages 306 right through to 311 or so of your text, because it gives you an outline and examples of the different types of rock and the rock cycle itself.